we're on lesson 125. We're busy finishing up with quadratic patterns. Last bit of those higher level questions that we can get, not the recipe sums. If the number pattern is given to me, I can already see that it's definitely not linear, because I can't see that there's a constant difference. So we know that it's going to be quadratic. But listen to this question now. I'm changing a little bit from the one I let you think about yesterday. If the questions just said, there's the pattern, please determine the first difference between the 25th and 26th term. Now there's two ways of doing it. The long way, which is popping into your mind immediately. Go find 3n. Once you found it, actually work out the 25th and 26th term. When you got those values, just see the difference. There's nothing wrong with that, but it's going to be a double as long sum as what I'm going to show you now. The principle of it is that you will always have a constant second difference, but the first difference, help me, this first difference is going to be -1 plus 4, which is going to be 3. -2 plus 1, which is going to be -1. -7 minus is a plus 2, is going to give me. So, is there a constant difference there? No. But is there a constant second difference? Which will be -1, -3 is -4, -5, -1 is? Because it's negative over negative. Showing me that the second difference is the same. But now that's not the question. You've got to get into the habit of it's always going to be, now do our little formula. We're going to do it. This is the second part of the question says find the general term. We're going to do it just now. We know our formulas. But this part of the question says only find the first difference between the 25th and 26th terms. So somewhere here in the first differences, there's going to be a term that's going to be between the 25th and 26th term. That's what we tried to do yesterday just before the bell went. So which term will be in this linear pattern? Will be between the 25th and 26th. 25th, 26th, 25th. Let's think about it again. If this is term number 1, it's between term 1 and 2. This is term number 2, which is between 2 and 3. Term 3 is between 3 and 4. Term 4, 4 and 5. 5 and 6. So term what will be between 25 and 26? 25. Okay, so it's a logical deduction that we're making here. So I know that it's going to be term 25. Now in an exam, if you thought it was 26, would you lose all your marks? No. Because that's one thing that they test you. Knowing, can everybody get that principle? That if I want, so in other words, if I want the first difference between the 30th and the 31st term, it would be the 30th. Excellent. So it's always going to be one less. But think about it logically. The first one was between 1 and 2. Second between 2 and 3. Third, 3 and 4, etc. So the 30th one would be between 30 and 21. So I could ask you the difference between the whatever, 2000 to 2001 would be term 2000. Got it? But now how would I find that? Because it is it's a linear pattern. So actually what I'm asking you is which term is 25? Term 25 in the linear pattern. Linear pattern. So first we have to go get the linear patterns formula. And the linear pattern is Tn equals A plus C. Good. And now the A part is what? It's going to be -4. Okay. So it's as if we are closing up that quadratic pattern, only looking at the linear one. So then my A part would be -4 plus the B, like you did in grade 8 and 9 and 10. And to find the B part, what do? You have to substitute. We substitute in with? To find the n. Because remember, I can't substitute to 25 now yet because I don't know what B is. First, we have to search for B. For that, we need to substitute the n with 1. Who taught you to substitute 1? Your grade 8 teacher told you, and your grade 9 teacher, and your grade 10 teacher. Because that's the way to find B. And what was the first term? 3, not minus 4, 3, because we're working with the linear pattern now. It's only that little piece here that we're working with. And in that one, the first term was equal to 3. So that would be negative 4 plus b equal to 3, giving me b answer 7, because minus 4 becomes a plus 4 and the answer is 7. What did I just find? That the general term of the linear pattern is negative 4n plus 7. Am I finished? No, I didn't answer the question. They wanted me to find, but they didn't say that. They wanted me to find the 25th term, which you might have thought is the 26th term, so you'd lose 1 mark for not knowing that it would be the 25th one. That's negative 4 times with 25 plus the 7, giving me an answer of, is it 90, negative 92? Please check up on me. 90? Oh yes, 3, thank you. So that means over here in the 25th place there, that would be negative 93. The difference, the first difference between those two, and I don't know what they are, but the difference between them would be 93. Well, minus 93. Now you could have done it by finding the general term, like we're going to do now, but this is what I wanted to show you because it's something that you've got to realize. In all quadratic patterns, there is still a linear pattern because the first differences make up a linear pattern. And the whole thing about between the 25th and 26th one is term number 25 in the linear one. Have you got that principle? All right. Now to find the general term, this is our bonus marks in a question paper because you're going to get this easy marks. What were our formulas? 2a equal to the first one there.
3a plus b
equal to that second one there.
a plus b plus c
equal to that one there. And our steps are 1, 2, and 3. Never going to change. Right, so for first step, we've got 2a equal to negative 4. So a is equal to
negative 2.
Second equation, 3a plus b equal to 3. So a was negative 2. Correct?
Yes, miss.
So that b would be equal to, you don't have to show your steps. Negative 6 there will become a positive 6, so that would be 9. Third step, a plus b plus c equal to negative 4. Remember, it can't be anything else than the first ones. A value was negative 2, b value was 9. So my c value, negative 11. I agree. So that my general term is negative 2 n squared plus 9n minus 11. And this would be around about 4 or 5 marks. That's our recipe. That's our bonus points. Okay, we're going to continue now with this same sum. I'm going to ask you my third question. I'm going to erase now. To say what is the minimum value that this will be. Would that be correct answer? If you look at this pattern,
Yes, yes.
it's a negative,
So
so it's going to have to be a okay, because we're thinking our own sum now. For which term, or just which term will have the maximum value? Something, seeing the recipe here, that they're going to ask over and over again. This we've done. So who can tell me? How will we find out which term? So that means n. I've got to find the n for which this pattern will be a maximum value. How do I do that?
Completing the square.
Completing the square or?
Turning point.
Okay, which one is the easiest?
Turning point.
Definitely. Are you with me? So let's do turning point. If you've got a choice, you do the easier one. So for the turning point formula, that would be
Minus b over 2a.
minus b over 2a. So the minus b would be negative 9. Right? 2 times a, negative 2. Answer is 9 over 4. I'm done. What did I just find here? The x value is actually the n value. So for term number 9/4, that's a bit of work for me. Are you with me? So it cannot have that value. It's because I thought it out for myself. It wasn't part of this question. How can I have term number n be 2 1/4? So what does it teach you? Don't think a sum out and think it's going to fit. It has to be something. This turning point is for a parabola. Would be at 2 1/4. But it can't work for number patterns. Because in a number pattern, n has to be a natural number. So if this was a question paper, it obviously had a mistake in it. Okay, but how would we find it? By finding the turning point. And once we've got n, we're done. Then we know for which term we'll have a maximum. Do I know the maximum? I could find it by substituting the n with that, but it doesn't make sense if it's a number pattern. Right. Okay, we have to read question F together. It says, a quadratic number pattern has a second term equal to 1, a third term equal to -4, and a fifth term equal to -23. What to do? Write it down. What have they given you? They say the second term is 1, the third term is -4, the fifth term. So they're giving you term 2 and 3 and 5, but they're not giving you 1 and 4. You follow me here? So they say that the second one is 1, the third one is -4, and the fifth one is -23. So what am I short here? X and Y, because we love them. X for the first, because you can't not have a first term, because that changes the whole parabola, remember? Yes. If I say term 1 is gone, then term 2 is now term 1, then the whole thing is shifted. It's not the same thing. So term 1 is missing and term 4 is missing, and you can't make them both X. Unless they said something about term 1 and term 2 is half each other or something like that, then you can. What to do?
Find the differences.
You have to always do first difference
Second.
and second difference. I am yes. 1 minus x. -5 degree. -4 minus 1. Y plus 4x in it. Because it's y minus -4. And 20 minus 23 minus y. Do they have a relationship? No. Nope. It's first differences. And did they have to tell me that this was quadratic? Yes. Because there's no way I can see that it's quadratic with all those x's and y's there. But then, therefore, I know that the second differences will be equal to each other. Whatever I'm going to get here is going to be equal to each other. Now, what am I getting there? First of all, minus 5 minus 1
plus
Are you getting that shortcut technique of mine? If it's -5, subtract that, it changes the signs to a negative and a positive. This will be y plus 4 plus 5. Please don't take shortcuts and immediately write 9. Show the marker, everything. Over here, -23, negative y,
minus 1
minus y,
plus 4.
minus 4. Remember, everything is now timed with a negative. Or you've got to write negative.
Is it a plus?
Okay? So if you subtract that, it's going to be minus times a minus. Now, I normally like to simplify that a little bit. So here we've got x minus 6 degree, or minus 6 plus x, no problem. Here we've got y plus 9, and here we've got -2y, -27. Just check me on my adding. Right. So what do I now have? Second differences, which I know are equal to each other. So therefore I can put these two equal to each other,
And then
those two equal to each other, and even those two equal to each other. What's the best one that they gave?
x plus 6 equals to y minus 2.
Why?
It's
Because it's only one variable. Do you see it?
Oh, you have to think.
This is going to be x minus 6, that's equal to y plus 9. That will be with a mark knowing that you're putting them equal to each other. And that one will be y plus 9 equal to -2y, -20. 7. So for the whole equating is where you're going to get your mark for, knowing that you've got to take those. So normally the marks go 1 for first differences, 1 for the second differences, for the actual doing differences and doing them correctly with the negatives and stuff. So this is not level 1, right? The level 1 ones was with normal numbers. Now that we've got them, we have definitely got simultaneous equations. And again, like the previous one, they helped us because of this only having one variable. If it had 2 variables and 2 variables, then so be it. We do simultaneous equations. Get the one x or y alone and put it into the other one. With this one, I can definitely first solve for y, which will give me 3y equal to negative 26. And y is negative 12. For this one,
so you're going to substitute.
now I'm going to substitute. Please, do you see where I'm going with this?
Yes,
If this was 1 and this was 2, I'm going to say here,
2
into 1. Please don't write it here. I'm all the time telling you, please set out your questions correctly. Use the paper. Okay, also, even if it's a full-in question paper, whenever put the paper onto a photocopy it on both sides so that you've got space on the left if you need some more space. Okay, so then this would be x minus 6 equals y, that's negative 12, plus 9, and we solve for x. So the x will be 3. Okay, what was the question? I didn't read the question, did I? Calculate the second difference of the pattern. Oops, I haven't answered that. I would have thought the question would have been find term 1 and term 4, the missing ones, which you could have named anything you liked, A and B, so you have A and B here. So did I answer the question? They said find the second difference of the pattern. So I'm needing this. Now do I have it?
You do.
Because those are all second differences and they should all be the same. So if I go here and I substitute x with 3, the second difference should be negative 3. If I go here and substitute the y with negative 12, it's still negative 3. If I go here and substitute the y with negative 12, it's plus 24 minus 27 is still negative 3. But the question was, what is the second difference? So the second difference is choose your choose, which would be 3 minus 6 is negative. Any which one of them. And if you only said negative 3, that's fine. That's what they wanted. Okay, then they ask you to determine the general pattern. Normally that's what they do. Somewhere the test will have in the pattern. Alright, so where do we go then? Hopefully, please, you're going to redo this thing. And you're going to write x is 3, y negative 4, negative 12. What am I doing? Are you following me? So I'm substituting x and y in so that I actually have a number pattern without x's and y's. And to do the rest of the sum would be easy. Can I stop there with this particular question because we're practicing the whole thing over and over again. So first differences, second differences we already know has to be negative 3. Are you with me? Alright? And then I can work out my A, my B, my C, find the pattern. Good. Alright, on the consolidation exercise on page 48, number F says, number G says, a quadratic number pattern has a constant second difference of 6. Okay, going back to front here. Constant second difference of 6. The fifth term is 80. The 10th term is 315. Find the general term. What? Okay, so we read again. We've got our quadratic number pattern. I don't even know what's going on here. But I know that the second difference is going to be? Okay, so I don't want to do too much because I have to work backwards now. So then obviously there's going to be a first difference, which they say nothing about. They say that the fifth term is 80 and the 10th term is 315. Okay, so the first term, goodness, so there's a 1, 2, 3, 4, 5 terms. First term is 80, 6, 7, and then number 10 is 315. So how am I going to do this back to front here to get to that answer there? And there's lots of difficult ways of doing it, but I want a nice innovative way. Any ideas? Let's try.
Won't you use like your formula and substitute the 6 like with the A and
Then you'll get your A value.
and you substitute one of those positions and then with the
I like what
N,
you're thinking.
you substitute the position number where the thing is sitting on, like with the fifth.
I like what you're thinking. I like what you're thinking because you're going for this. Right? Then for term number 5,
Yes.
we know that the answer is going to be 80 and we're going to substitute the N with a 5. We can find our A by saying 2A is, are you with me here? Let's see. I'm going to have you work on it a little bit for yourself, but I'm trying to help you here. So once I've got that, A is 3, right? So it's only 3 times 5 squared plus 5B plus C. What's happening here?
It's a
Two variables?
No.
Yeah. Because if I do that, I'm going to do exactly the same thing here. This was now term 10. So we're going to say term 10. So with a 3 there, we're still going to have a B and a C. So we're going to have an expression with B and C, expression with B and C. Are you with me? Do it that way for homework, but then also, couldn't you maybe work it some way around from the bottom?